Welcome, grade 10 learners. Welcome to Geography grade 10 preparation for junior examinations. Right, you are going to write a junior examination, a full examination paper, and you must understand that your full paper is a paper which is to be written in 3 hours, and that is going to have a total mark allocation of 150. So being your first time to sit for a full paper, it means you must be very prepared to be able to address the basic requirements of the paper, because this is going to be a full scope paper covering first topic and the second topic, and also covering GIS and map skills. Right, so as usual, we know that our first topic is the atmosphere, which I understand you are by now must be in a position to be able to answer every question which comes out of that topic because you have mastered it. Then within term 2, that is geomorphology, and then geographical skills will be incorporating them and encompassing them in your studies in relation to the atmosphere, in relation to geomorphology, and also you'll be doing map calculations. Right, basically that is the setup of the paper. So it's question number 1, 60 marks. In question number 2, geomorphology, 60 marks again to make a total of 120 for section A. Then we go on to section B, that is a total of 30 marks. So if we say 60 plus 60, 120 plus 30, that gives us a total of 150. Right, instructions, you must be familiar with them. I will highlight on an important instruction that I think most of you will tend to ignore. May you please pay attention to this instruction. Number 10. Units of measurement must be indicated in your final answer. For example, 1020 hectopascals, 14 degrees Celsius, and 45 meters. You will not be awarded marks if units are not indicated. I think that is very important. You must note that you are supposed to give your answers in with units of measurement if it is a question that requires you to identify something with relation to the units of measurement. Right, and also number 9 is very important. Answer in full sentences, except when you have to state name, identify, or list. If the question is saying describe, you cannot describe in 2 words, or you cannot describe in 1 word. If it says explain, you cannot explain in 2 words. You must give a full statement, which actually gives details to the question. Right. That besides the point, or just highlighting on important instructions that you need to encompass in your examination, that you need to keep on reminding yourself as you get into the examination. Right, let's move on to our questions. We are going to look at question number 1, which is a question on climate and weather, on the atmosphere rather. Right, our first question is saying, it's a multiple choice question. And the first one requires us to identify the gaseous layer that surrounds the Earth. What is the gaseous layer that surrounds the Earth? That is automatically the atmosphere. The atmosphere, by definition, is a layer of gases that ultimately surround the Earth. So it means just anywhere above the Earth's surface, we have the atmosphere, which is made up of different gases in different percentages. I understand you know that. Temperature inversion takes place in. What is temperature inversion? I will just summarize here. Temperature inversion is increase in temperature with an increase in altitude. What are we saying here? We are saying as height above sea level increases, the temperature is also increasing. So if you see a situation whereby the temperature is increasing and the height is also increasing, that is a situation of a temperature inversion, and that happens in 2 layers of the atmosphere, which is the stratosphere and the thermosphere. If you refer back to your structure, or if you refer back to the layers of the atmosphere, I think you can refer back to that and see. Where the profile is positive, it means there's an inversion there. Temperature is increasing with altitude. In the troposphere, I understand in this layer, the higher you go, the cooler it becomes. But if you go to the next layer, it becomes the opposite. It becomes positive. The temperatures will start to increase with altitude. Right. Number 113, it says the atmospheric layer that contains ozone layer. Where do we find our ozone layer? What is the ozone layer? We talked about the ozone layer as the layer which is a protective layer from harmful rays of the sun. The sun produces what we call the ultraviolet rays, which are harmful to human health and to ecosystems on the earth. So there's a layer responsible for limiting the amount of those dangerous rays that can reach the Earth's surface, which is called the ozone layer. So you find our ozone layer in the stratosphere, which is B. All right, moving on to the next question. The atmospheric layer that is closest to the Earth's surface. From the Earth's surface, we start with the troposphere. I think that is clear. The layer that supports life. 115. It says the layer that separates mesosphere from the thermosphere. Whenever we talk about a layer separating two distinct, is a pause. So if we are on top of the it separates the mesosphere from the thermosphere. We are looking at the pauses. So on top of the troposphere, we have a tropopause. And then we move on to the next layer. On top of the stratosphere, we have the stratopause. On top of the mesosphere, we have the mesopause. So a pause basically is a layer that separates the beneath layer and the top layer. But the layer is named after the layer which is beneath. The end of the layer as we go up marks the boundary and is named after the layer that is beneath. So after the mesosphere, we have the mesopause. Then we'll move on to the thermosphere. So it's A. Right. We move on to the next question. Weather activities take place in the. Where do we have weather activities? Where do they happen? Where do we experience weather? The weather conditions, they happen in the lowermost air surface, in the troposphere. That is where we experience weather conditions. The next question, number 117, temperatures decrease in height in the following layers. We are looking at the opposite of the inversion. What did we say about our inversion? If you are clever enough and if you know an inversion, you just go back to the inversion and see there's stratosphere and thermosphere, which means the two remaining layers must have a negative temperature profile. So which are those two? Automatically the troposphere, we know that. Troposphere and our mesosphere are the ones which have got a negative temperature profile, where there is a decrease in temperature with an increase in height. Right, we move on to question number 1.2. Choose the term from the following, from column B that matches the description in column A. Write only the letter A to I next to the question number. Right. The radiation by the Earth's surface is known as. There is insolation and terrestrial radiation. Insolation, always remember, is incoming. And then terrestrial is also called long wave radiation and is outgoing. So we are saying during the day, we have insolation. We have incoming solar radiation. The sun is heating the Earth's surface and the Earth's surface is receiving the heat. That is insolation. And at night, the sun would have set. There's no more sun in the sky. What is now going to happen to the heat? The heat that was received during the day is now going to be lost into the atmosphere through a long wave radiation. So that is terrestrial radiation, which is Z. The transfer of heat between substances that are in direct contact. Direct contact is conduction. Convection, it happens through currents, convection currents. You understand? Like that, the heat is transferred through the air. Right, by convection currents. Number 1, 2, 3, the atmosphere is heated by the process known as, we've talked about that. The atmosphere is heated by terrestrial radiation. What heats the atmosphere is not the sun directly, but the heat that comes from the surface is the one that heats the atmosphere. This outgoing heat is the one that we feel. If you are complaining of high temperatures, it's not the insolation from the sun, the direct sun's rays. They are received by the Earth's surface and then they are released by the Earth's surface. As they are released, they are the ones that cause high temperatures, or they are the ones that cause us to feel hot. So it's not the sun's rays directly, but it's the heat from the ground. That is why sometimes you would feel even it's hot during the night. Why does it become hot during the night when there's no sun? If it is the sun that heats, it must tell you that it's not the sun that heats directly, but it is the ground that heats. The ground, when it releases heat, that is the heat that heats up the atmosphere. And that is the reason why sometimes, even at night, it feels very hot. It's because of terrestrial radiation. Right. The process whereby heated air is rising is referred to. When heated air rises, we've talked about that. That is convection currents. Right. The act of sending the sun's rays back in the direction it came from without much absorption. That is reflection. Reflection mainly is done by shiny surfaces. For example, shiny clouds, they send back the heat. They don't absorb it because of their shiny color. The shiny color sends back the heat. Like if you reflect the sun's rays on a mirror, they are sent back. That is reflection. Then scattering is directionless sending of heat. The heat is just scattered in any direction, just sent in different directions. That is scattering. The process whereby clouds and solid matter absorb energy. It's process whereby clouds and solid matter absorb energy. That is absorption. When energy is being absorbed, is absorption. Like for example, dark clouds, they can absorb the heat. Right, let's look at number 7. Insolation is in the form of, incoming solar radiation is in the form of what? Is in the form of short waves. This is incoming and this one is outgoing. Long wave radiation is in form of long waves. Short wave radiation is in form of short waves. The distinction here is these long waves that are invisible and these ones are visible. If the sun is in the atmosphere, you can actually see the sun's rays. But long wave radiation is invisible. You just feel that it's hot, but you don't see the heat rays. You just feel them in the atmosphere. Right. Number 128, it says, occurs when small particles and gases diffuse or split up in the sun's rays in random directions without altering the wavelength. I've talked about that. That is scattering. Right. That takes us to the end of question 2.1.2. We move on to question 1.3. It talks about global warming. We're not going to go through the text. And this graph here is showing us the rise in global temperatures from 1881 to 1890 going until 2001 to around 2010, where we see there is a sharp increase in the global temperatures in degrees Celsius. Right, we're going to answer the questions. Our world is heating up. What concept does this statement refer to? Our world is heating up. Whenever we talk about the world heating up, that is global warming. The general rise in the world temperatures is global warming. Describe the general trend in the global warming. If the question is asking you about a trend, we are saying what pattern is being shown here. From 1890 to around 2010, what pattern? The pattern is increasing. You are seeing that is increasing in general. So the trend is increasing. So whenever I asked about a trend in history, in geography, remember, a trend can be increasing, decreasing, or it can be constant. According to the graph, during which period was the Earth coolest and warmest, respectively? But when I'm answering this question, can you please be specific? This question is saying respectively, meaning to say in that order. If you don't indicate, it means you must give the answers in the order of first the coolest and second the warmest. If you oppose the two, you start with the warmest and the coolest, even though the answers are correct, but you did not respect the directives of the question. You must answer the question in sequence of the first coolest, the second warmest, if you don't want. But what I encourage you is, I know most of you will get lost. Maybe English is a problem. Respectively, you forget what it means. Respectively means in that order, because there are two questions there which need to be answered. So there are two answers which need to be put in place. But if you don't specify this answer is for this answer is for this, you need to answer them in the order. If you just put two there, they must be in the order of the first must be for the coolest, the second must be for the warmest. But what I advise you is to write coolest, then you give, and you write warmest, then you give, so that you don't confuse yourself and you don't lose those marks. So in this instance, we are saying at the coolest, we go to our graph and we just check. If we see this is the lowest here, this is 1901 to 1910. So the coolest is 1901 to 1910. And then the warmest, automatically, that is the last, 2001 to 2010. If you are just looking at our graph, this is the highest and this is the lowest. Right. Explain the relationship between the extreme weather conditions and crop failures. What is the relationship between extreme weather conditions and crop failures? Automatically, those two are directly related. When there's extreme weather, crops are going to fail. So, extreme weather, we can say extreme weather results in drought conditions. That kill crops. Crops cannot do well if there is extreme weather conditions or droughts. Or we can also look at extreme conditions on the soil fertility. If there are extreme conditions, it means the soil fertility is going to be affected, and that is also going to lead to failure of crops. Or if there are extreme weather, it can result in flooding. It also flooding is going to damage the crops, and there's going to be a crop failure. So basically, the relationship there is such that if there is extreme weather conditions, it is also going to result in. Extreme weather conditions is not only in the context of high temperatures. It can be extreme in the extent of cold temperatures, excessively cold temperatures. If there are extremely cold temperatures, automatically it leads to freezing, and much of the crops are going to die. Or the non-frost resistant crops, they will die because they can't resist extremely cold conditions. If it gets extremely hot, it leads to drought conditions. There are water limitations. It leads to crop failure, or the crops will die. Or if there's excessively high temperatures, the fertility is going to be lost, and ultimately ground moisture is also going to be lost. Crops are going to fail. So there is a direct relationship between those two. As extreme weather persists, crop failures also persist. They are directly related. Right. In a paragraph of approximately 8 lines, discuss the impacts of global warming on the economy and suggest sustainable strategies that people may use to reduce global warming. Right. You want to look at the impacts on the economy, then the strategies that can be put in place. Number one impact is increase in diseases. Remember, global warming leads to a number of diseases. What is going to happen if workers are exposed to a number of diseases? That leads to reduced productivity. The workers won't be productive because they are sick. Or we can say increased medical bills. Maybe for the government needs to spend more money to acquire medication for the people, because the people are sick because of global warming. So it affects the economy. And also, we can look at it on the perspective of agriculture. affects farming negatively. Farming is going to be affected. How is this an economic impact that agriculture is affected? It reduces the income of farmers. Or we can say it causes an increase in food prices. Food prices are going to be high because there is a scarcity of food commodities because of the effect of global warming on agriculture. So basically, that's the idea. Not all of the ideas, but that's a picture of what you must try. Try to find the impact of global warming and then relate it to how it affects the economy. Then you go on strategies. What can be done? With global warming, we now try to find ways, use of alternative energy sources. Or even global warming because of the usage of thermal electricity. Let's try to find other alternative means of energy. We can also encourage people to use public transport. Let's use public transport so that we minimize on the damage to the environment caused by emissions of pollutants into the atmosphere. You can also use education and awareness. People must be made aware that whatever activity that they do, which is harmful to the environment, which contributes to global warming, is equally deadly in the future. So if they are equipped with such knowledge, it means people will act responsibly and they will try to avoid some of the activities that contribute towards global warming. Right, that's the idea, but that's not all. It means just a picture or how you must structure your answer, how you must focus. So this is a paragraph question. Your discussion must be balanced. In that instance, you are saying you must not address one side of the question. The question wants you to address impacts and also wants you to address sustainable strategies. So you cannot only address one side, address the two sides, at least two ideas on the impacts and also give two ideas on the strategies. Right. Fig 1.4 shows types of rainfall and answer the questions. It gives us a frontal rainfall and orographic, and it shows us the precipitation and also the temperature. Frontal rainfall, which is experienced over Cape Town, and Pretoria receives orographic rainfall. Right, during which season does Cape Town receive its highest rainfall? We understand that Cape Town receives orographic rainfall, which is brought by the coming of the mid-latitude cyclones. That happens during the winter season. And may you take note of this. If the question is saying season, months are not a season. Because some of you tend to look at the graph and then you see that highest points of the graph are somewhere June, July, August. Then you say between June or between May and August. This is not a season. After identifying the months, please give the season. You understand that June is a winter month in the southern hemisphere. So give a season, not to give the months. The question is not saying which months. If you write months there, your answer is going to be wrong. Right, number 142. Make the rainfall X and Y with Pretoria and Cape Town respectively. Right. So it implies that your rainfall match the rainfall X and Y with Pretoria and Cape Town respectively. We are saying rainfall X is frontal and rainfall Y is orographic. So we want to match those rainfalls with Pretoria and Cape Town. So automatically it means Cape Town is the one that receives orographic, while Cape Town is the one that receives frontal, while its orographic is experienced in Pretoria. So it means X is our frontal. Frontal rainfall is experienced in Cape Town, and then orographic is experienced in Pretoria. So this one matches with this one matches with this. Right. Explain the relationship between the rainfall pattern and the temperatures of Cape Town and Pretoria. We want to relate rainfall to the temperatures. If we see here, our temperatures are on this side, and our Cape Town is there, and this is our graphs which show us the amount of rainfall. We want to check out the relationship between rainfall patterns and temperature. What is happening here? Rainfall is high during these months. What about the temperature here? The temperature is low. So we are saying the relationship is there is that Cape Town receives much of its rainfall when the temperatures are very low, just 10 degrees Celsius. That is where it is experiencing the highest bars of rainfall there. And let's look at Pretoria. You look at January, February, March, the temperatures are slightly higher. And then we look at November and December, the temperatures are also slightly higher there, above 10. So the relationship there is such that, to summarize, we are saying for this one, Cape Town receives its highest rainfall during the coldest months. During the coldest months. Ultimately, we are saying during the coldest months in winter. And what about Pretoria? In the case of Pretoria, it receives its highest rainfall during the warmest months. Which is typical of in summer. So that's the relationship between the temperatures and the rainfall patterns. When it's cold over Cape Town, they receive the highest rainfall during winter. When it's warmer in Pretoria during summer season, that is where also they receive the highest amount of rainfall. Right, we move on to question number 1.4.5. Discuss the process of the development and formation of orographic rainfall. Why? I'll use the illustration to explain. What you are seeing here is what you're supposed to explain. Right, we are saying there is warm and moist air over the ocean. This is probably the Indian Ocean, where there's a warm ocean current. Onshore winds from the Indian Ocean are warmed by the warm ocean currents, and they also pick moisture from the ocean. They become warm and moist. As the winds blow inland, they are forced to rise by a barrier. That is why we are saying it's orographic or relief. There is a relief feature here. You are seeing this forces the air to vertically rise. What happens as the air rises? It reaches the dew point, or it reaches the condensation level. The moisture in the air starts to condense and clouds form. There is formation of clouds. And as the clouds form, more and more moisture is fed into the clouds. They become saturated. And then they release the moisture as rainfall. which is now our relief rainfall or orographic rainfall. So that's the picture of how you describe that. You describe warm and moist air from the warm ocean. It has moisture. It is forced to rise by a barrier or a relief feature. As the air rises, it is are forced to go up and reach the dew point. As it reaches the dew point, the temperatures are becoming lower, and the moisture in the air begin now to form water droplets, which are in a form of cloud. And as more and more moisture is fed into the clouds they become saturated and they release the moisture now as relief rainfall. That's the picture of what you are supposed to explain there. Right, we take us to question number 1.5 on the synoptic weather map. Let's see the questions. What is a synoptic weather map? Right, that is basically an open question. We can say it's a map. A synoptic map that represents summary. Summary of a day's weather. So basically, synoptic map gives us a summary of the weather of a given place in a day's time. It summarizes the weather conditions, which means all weather elements are summarized there. The maximum temperature, the minimum temperature, cloud cover, wind direction, wind speed, all those aspects of weather, they are summarized there. Precipitation, all those on a synoptic map. Right. Identify front A on the synoptic weather map. If you are to identify the fronts, you must not struggle. We know that we have main two fronts, the cold front and the warm front. Our question is asking about front A. Right, these fronts you see by these indications. If you see a line with these triangles like this represents a cold front. And if you see a front like this with some semi-circles, something like that, it represents a warm front. Then also there are instances, sometimes you tend to find that there's something like this, a triangle, a semicircle, a triangle. This is called an occluded front. Right, so basically here, this is a cold front. Name the line marked C on the map. Let's go and let's check for C and figure out what kind of a line is it geographically. The line marked C, if we check here, this is the line that we are referring to, this line here, and this line here that has a number there, continues going like that down. What kind of a line is that on synoptic maps? That is basically an isobar, a line joining places of the same atmospheric pressure. It's an isobar. Provide two map evidence that this synoptic weather map represents summer conditions. We are told that is summer conditions, and we want to substantiate why is it summer. Number one is this cold front here. This cold front is further to the south. This happens during the summer season. This one here, the cold front, means further to the south, is one piece of evidence. And also, if you check around, you can see that the amount of cloud cover over the interior. This is full cast. That one is 3/4. That one is full. That one is full. So, if you also check, there is high cloud cover over the interior. That happens during the summer season. So that cloud cover over the interior is also evidence of, and also if you check here, what is this? A low pressure over the interior. What do we call that low pressure over the interior? Is called the thermal low. It's caused by the sun's heating of So the sun only effectively hits during the summer season. So it's also another piece of evidence that you can also use. And also generally you can check the temperatures. The temperatures over the interior are generally high: 27:18, 25:15, 29:12, 29:20. So you can also use the temperatures are high over the interior. It's also another piece of evidence that you can use. And what else can you use to substantiate that there is? Check also here on Beira, there's this thing written Elin. This is a tropical cyclone. That symbol here is a symbol for a tropical cyclone. And we understand that our tropical cyclones, they affect during the summer season, late summer to autumn. So there's tropical cyclone Elin here, which shows that this is typical of conditions that exist during the summer season. So I think those pieces of evidence, you can safely use them to support the fact that this is a summer map. Then it says, describe the weather conditions at station B in Harare, referring to the following factors: cloud cover, wind speed, and wind direction, air temperature. Right. So this is the enlarged station for Harare. We need to identify these elements. Right. The first element is that of cloud cover. We can see our cloud cover here is fully covered, which means it's 8/8. Or we can say it's 8 octaves or it's overcast. Then wind speed, we see it here. This is a full feather, so it represents 10 knots. Look at wind direction. This, the pointing of this, where is it pointing towards? It is pointing towards the southwest. Southwest. That is our wind direction. Air temperature, that is the higher value of temperature. Between the two, there's 17, which means this is dew point, and air temperature is 19, which is the higher one. So it's 19 degrees Celsius. Remember, do not leave units of measurement. It's 19 degrees Celsius. Right, then dew point temperature is the lower one. We have seen it there is 17 degrees Celsius. Right. There are high chances of precipitation at station B. In Harare, there are high chances of precipitation. Provide two map evidence to support this statement. Why is it that there are high chances of precipitation? Number one is the cloud cover. Overcast conditions. The sky is fully covered. That is gives us evidence that it's most probably going to rain soon. And if you also check here at Beira here, and also we see that Harare is somewhere here. This tropical cyclone is coming because it will be moving from the east going to the west. So it's approaching. The approaching of the tropical cyclone Elin. It is also going to bring rainfall. There's approaching tropical cyclone Elin. And also besides that, we can look at the difference, the range of temperature between the dew point and air. If the difference between dew point and air temperature are almost the same, it means there are high chances of rainfall. So in that instance, we are saying there is only a difference of 2 degrees Celsius. So it's also evidence that it will rain very soon. If there's a wide range between the two, it also means that the air is dry and there are no chances of rainfall. Right, with that being said and done, I can safely say that we have come to the end of the atmosphere question, which is question number 1. Let us proceed to question number 2, which is geomorphology. Right, question number 2, the first question is saying the outer core or crust is the outermost layer of the earth. From our understanding, we know that the earth's crust is the outermost. Then the mantle or crust is made up of segments called plates. The plates are part of the earth's crust again. The inner core is solid because of extreme temperature or pressure, What makes the inner core solid is because it is carrying the weight of all other layers. It's exposed to pressure. 214. The layer found beneath the crust is, just beneath the crust we go to the mantle. I think you still remember the earth structure. The outer core is dense and liquid due to extremely high, is dense and liquid because of temperatures. Then the outer core or the crust is important because plants grow on it. We can only grow crops on the earth's crust and not anywhere else. Inner core or mantle is there in the molten state. The inner core is solid. We've talked about that because of pressure, and the mantle is made up of what? Molten rock. Right. Number 2.2. It says rocks that are formed when magma cools and solidifies. Magma cools and solidifies. What kind of rocks are those ones? Those are typical type of igneous rocks. The igneous rocks form due to volcanic activity. They form from the hot liquid rock from the interior, from the mantle, as the hot liquid rock finds its way either within the Earth's crust or out of the Earth's crust as an extrusion feature. They solidify, they give us igneous rocks. This rock type consists of layers or strata. Layers or strata, the rocks which are layered are sedimentary. And for that instance, we are saying they are made up of particles of other rocks. Those particles, they go through a process of sedimentation. They accumulate layers one on top of the other. And over time, they go through the process of cementation, whereby those particles, they start to stick to each other and form a type of brittle rock. Those sedimentary rocks, they are usually not very strong. They can break because they are made up of different particles, and some of them, they can be carved into different artifacts. Right. Rocks formed when other rocks undergo change due to pressure and temperature. Whenever you hear the word change, think of the biological process of metamorphosis. So, rocks which change, they are metamorphic. So, metamorphic, it means those rocks were originally either igneous or they were sedimentary, but they were exposed to extreme temperatures and pressure. Because of those two aspects of pressure and temperature, the rocks are forced to undergo a process of change, and they completely change their form to become a completely different rock. So sedimentary rocks, igneous rocks, metamorphic rocks rather, they originate either from igneous or from sedimentary. And because of exposure to higher temperatures and also exposure to a pressure, those rocks tend to change their form and they completely change into another form. Only if you can remember metamorphosis and you will remember that rocks which change their form, they are metamorphic. Right, we will look at number 2.2.4, the remains of plants and animals found between layers of sedimentary rocks. We are looking at the remains of plant and animal. What kind of things are those? The remains. Those are what we call the fossils. Process that cause rocks to form, break down, change, and reform over time. We are saying the rocks, they change. Maybe it's an igneous form in the first place. It is a rock that originated from volcanic activity, but then it's exposed to weathering. It weathers out. The particles, they get washed. They accumulate maybe in a valley area or in a low-lying area. As weathering continues, the outer layers are weathered and they are broken and they are transported and they accumulate somewhere else. They cement, they form a sedimentary rock. Maybe that rock is buried underground. There are higher temperatures there. The rock changes again. It becomes a metamorphic rock. The metamorphic rock again changes into. So that was number 2.2.4. The response is the rock cycle. And we move on to the next question, number 2.2.5. It says processes that cause rocks to form. Process that cause rocks to form. Break, we've talked about that. That is basically a rock cycle, which is B, the cycle of the rocks. Rocks change from one form to another. So that is the rock cycle. Right, the igneous rocks that is used for monuments and tabletops. What kind of igneous rock do we use for monuments and for tabletops? Tabletops, you see that they are made of granite. We use the granite rock. Right, sedimentary rock that is made from plant material. Right, that is coal. Coal is a fossil fuel. It means there was a fossilization process. It implies that some plant matter died and got to be buried underground and went through the process of fossilization, changing form to become coal. So coal, basically, we are saying we are using dead plant material which has been fossilized over millions of years. Right. The rock that is formed when limestone undergoes changes. If limestone undergoes changes, it goes into marble. Right. That takes us to the end of question 2.2. We move to question 2.3. Refer to Fig 2.3, which shows continental drift and plate boundaries, and answer the questions. Right, we have those three types of plate movements. Right, this one you can see the plates are moving away from each other, which is A. That is basically what we call a divergence. It's a divergent plate boundary, and this one are moving towards each other. It means they are converging. And this one, they are moving or sliding past each other. That is basically a transform. Just a picture of what is happening on those plate boundaries. We are not going to go through the text, but we are going to look at the questions. Name the plate boundaries A, B, or C. We have already answered that. A is divergent. They are moving away from each other. B is convergent, moving towards each other, and that one is a transform, where they are sliding past each other. Name the current continents that are related to Laurasia and Gondwanaland. Right, if you see here, Laurasia is the northern continent, and then Gondwanaland is the southern continent. So we are basically saying which current continents are part of the north and which current continents are part of the south. So under Laurasia, we have North America, and we also have Asia, and we have Europe. Those are countries in the north. And in the south, the remnants of Gondwanaland. It's Africa, South America, and we also have Australia, and you can also add Antarctica. Right, those are in the south. So basically we are saying which continents are in the north and which continents are in the south according to the split of the mother continents into Laurasia and Gondwanaland, the major continent, Pangaea. Right, refer to the statement. Rift valleys are a site where continental landmass is ripping itself apart. Name the plate boundary this statement is referring to. If rift valleys are formed by continental landmass ripping itself, what does that mean? We understand rift valleys are formed by divergence. So with this statement, it refers to a divergent plate boundary. That is where there is a ripping off of the continental landmass, is splitting itself. Because of divergence, we tend to experience the landmass tearing itself, and then after the tearing, a low-lying area is created which comes in the form of a graben or a rift valley. In a paragraph of approximately 8 lines, discuss the importance of rift valleys for humans. Right, number 1 for tourist attraction. A country earns foreign currency. Because of that, because we are attracting tourists to view the rift valleys, then it's very important for that sake. And for the sake of tourism, also jobs are created. Due to increased tourism, we tend to find that through the multiplier effect, the tourism activities, they tend to generate more jobs that promote the level of income for the people. Then also rift valleys have fertile soil. They are very beneficial in the sense that they provide fertile soils which are needed for farming. And also for humans, they can be used as grazing land for livestock. You can graze livestock, farmers can graze their livestock in those areas. And also we can finally say the rift valleys, they promote research. Promote research and field work. Geographers tend to investigate into the rift valleys. They research on how the rift valley would be forming and how the divergence is taking place. And they might also be interested in knowing the rate of divergence. By how many centimeters is the rift valley growing? How much centimeters are the two plates moving away from each other? So basically, it is a field of interest for geographers, and they can also be able to investigate deeper into the aspect of tectonics. Right, we move on to question number 2.4. Fig 2.4 is an infographic on faulting and folding, and answer the questions that follow. Right, diagram number 1, it shows a symmetrical fault, an asymmetrical, an overturned, and a recumbent. Right, what you must know there is, with a symmetrical fault, the two limbs are equal, they are equally inclined, meaning to say it has a line of symmetry. We can divide this into two because this side is the same as this side. Asymmetrical, it means one side is overfolded than the other and there's no line of symmetry like here. We cannot split this into two. This side is general than this side. Then if you look at overturned, it means the landmass goes over another landmass. And the recumbent, actually there is strong force and there will be a crack on the landmass. Right, that's just a picture of what you must note. Right, identify faults X, Y, and Z. Fault X is caused by tensional forces. It's called a normal fault. If you look at fault Y, remember the forces are now different. This is tensional and this is now compressional. The force is compressional and that one now is a reverse. It's a reverse fault. And Z, we are seeing that there is opposite directional movement of the force. That is called a transform fault. Right, so it's normal fault for tensional forces, then a reverse fault for compressional forces, and then a transform for side forces. Right, one part, name parts of the fault labeled B and C. B, and C. Right. We have a part which is turned up like this, and another one at B is turned down. So we have an up fold and we have a down fold. Those two are named differently. An up fold, this one, the landmass has been folded upwards, but here the landmass has been folded from at the bottom. It's downward folding. So what are we saying here? We are saying an upfold C is called a syncline. Whenever the landmass is bended up like this, we call it a syncline. And when it's bended down like this, we call it an undecline. An undecline for an upfold. Sorry, I'm writing the confused thing here. It says for an upfold, that is an anti, because it's folded up, it's an anticline for this one here, because this landmass is stretching up and this landmass is stretching up, and the bend is on top. But if you compare with this one now, it's different. The bend is at the bottom. So this one is a syncline. So always remember an undecline for a fold which is upward. This an upfold is an undecline, and then a downfold is a syncline. So that is the basics of folding. When the landmass is bending upwards, undecline. When it's bending downwards, it's a syncline. Right. We move on to the next question. Describe the rocks on which the process of folding and faulting will occur on. What kind of rocks can we experience the process of folding and the process of faulting? Automatically, it means we need some special qualities in those rocks for those processes to occur. Right, so we start with faulting. Faulting, we are looking at the breaking of rocks. So what is the nature of rocks which can break, either if they are exposed to tensional forces or if they are exposed to compressional forces? Those rocks, they tend to fold, they tend to crack. Or those rocks which tend to fold like this. If a rock is exposed to pressure from this side and pressure from that side, these rocks, they tend to bend. What are the properties of these rocks which can bend if they are exposed to compressional force? Some will break, some will bend. So it means the properties of those rocks must also be different. So let's start with, let me clear a space here. I will just write here. Right, we are saying that 2.4.3. Right, we are looking at rocks that can fold first. What kind of rocks that can fold? It occurs on softer rocks that can bend. These rocks must be soft for them to accept to bend. If they are hard, automatically they cannot bend, they will break. So automatically it means in this instance, these rocks are soft. Mainly they are sedimentary rocks. And for that reason, they are soft and they can easily be turned. And then faulting, we are saying if the rock is exposed to pressure, it cracks. Which types of rocks fault? This occurs on rigid rocks. That cannot bend. They cannot bend or they cannot fold. They break. They develop cracks. If you expose pressure on them, they cannot bend. The only way for them to sustain is to break. They develop cracks and they break. So those ones are the ones that fold. So basically, if you check those two dimensions, it relates us to that fact that rocks have got different properties. And for that sake, we tend to find that some rocks, they tend to fold if they're exposed to pressure, and some of them, they tend to crack, develop cracks and break, that is faulting. Right, we move on to question number 4.4. Explain what will happen at point A in diagram 1 if compressional force is increased. What will happen at point A if compressional forces will increase? Here, we are seeing that compressional forces, this one is almost overriding that one there. And what is going to happen on that fold at A? I'll use this space here. So if compression increases here, there is more sideway force which is pushing towards each other. What is going to happen? The fold will snap. The fold will snap or it will crack. Because if more and more force is applied, automatically we are seeing that there's a weakness here. And this fold is going to slide over here. And this one will also be moving such that at the end, we have a complete break here. They will develop a fault. And along that fault, with continued compression, this limb here is going to slide over this because of continued compressional forces. Right. Discuss the development of symmetrical and asymmetrical folds in diagram 1, respectively. Right, I'll just use the diagram to explain. A symmetrical fold, what you need to analyze here is just to analyze the amount of force which comes from either side. Then you are done. How those folds form, they form because of compressional force. And in some instances, the compressional force is not balanced. There is more force from one side than the other. So here, with a symmetrical, what you need to explain is that the amount of force here is equal to the amount of compressional force here. So basically, it's same amount of force. This side and this side, they are balanced. The force coming from this side is equal to the force coming from this side. And hence, these two sides will be the same. These limbs here, they will appear the same. And then, if you look at an asymmetrical like this, what is the implication there? It means the forces are not balanced. This side has got a weaker force, and this side has got some other force. Right, so because of the differences, one side has got a lesser force, and this other side has got a stronger force. So, different forces applied from different sides. So as a result, tend to find that the bend on this side won't be the same as the bend on that other side because of the differences in the forces. One side has got a greater force. This side here is being forced strongly, and this side is weaker. So for that reason, you tend to find that this one becomes very steep, and this one is gentle. So that is how an asymmetrical fold, you just compare the forces from either side. Where there's symmetrical, it means there's a balance between the forces from either side. Where there is an imbalance, where there's asymmetrical fold, it means one side has got a stronger force and the other one has got a lighter or a weaker force. At the end, the limbs, they don't resemble, they don't look the same because of the differences in the force that are shaping them. 2.5, start the infographic on earthquakes and answer the questions below. Right, that is our infographic on earthquakes. Let's analyze what is here. There is a text. There is the impact of earthquakes. We are seeing the destruction of buildings and vehicles. And also we are seeing this illustrating the geographical location of the earthquake and how it spread through the waves. All those are shown there in the written text. We're not going to go through it. Name the features L, M, and N. Right, if you check here, L is the focal point of the earthquake where the earthquake starts. It's called the focus. The focus is a point within the Earth's crust where the shock waves originate from. That is where the earthquake starts from. And we have M. M is showing us this line here. What is that line? That is a fault line. It's showing us a fault line. Then N. This point is directly above the focus and is on the Earth's surface. So the point which is directly above the focus of the earthquake, which is on the Earth's surface, we call that the earthquake epicenter. So it's called the epicenter. Right. Then state human activities from the extract. Why? That may trigger or cause earthquakes. Human activities that may trigger earthquakes. Human activities, it says earthquakes can occur naturally or be induced by human activity, such as they are listed here. Number 1 is mining. Number 2 is fracking. Number 3, nuclear tests. So this and this and this are human activities that can trigger earthquakes. Explain the economic impacts of earthquake visible on the photograph. What are we seeing here? This car has been damaged. And what is the implication? This building has been destroyed. You are seeing there's destruction of this building here. So we want to look at the economic impacts. How is that going to affect economically? How is that going to affect the budget of the people? We are seeing that there is damage to the car. How is it a strain on the budget? Results in spending to repair. So automatically that is an economic impact. You are supposed to fork out money to repair that car, to fix it because it's been damaged. And also on insurances, the insurance companies, they will spend more money. Where are they going to spend the money? Paying for the people's damages. If you had insured that building, automatically insurance was supposed to pay. If that car was insured also, it means if it was insured against natural risks, then automatically it means the insurance companies have to pay for that. And also we talk about rebuilding of the structure. Money will be required to rebuild the property that we are seeing there. That property there is damaged. Like what you can see here, there's strong damage. Whether it's a residential property or it's a commercial property or industrial property, it needs to be rebuilt, and that is going to cost money. Right, that's basically the picture. Explain how earthquake may trigger tsunamis. Tsunamis, we understand that tsunamis, those are rough seas, whereby the water from the sea, it will ultimately flush out of the ocean and cause flooding conditions. How are those two related? Earthquake, how does it trigger a tsunami? When an earthquake happens over, or we can say, let's say, under the ocean, the waves destabilize the water. The seawater into sea waves. So basically, we are saying if an earthquake happens under the ocean, remember earthquakes have got waves. That way, those waves, as they happen under the water, they cause the water to be turbulent and develop into waves. And those waves now are the ones that we realize as the tsunamis. The water now develops into dangerous waves that will tend to swell out of the ocean and sweep over areas around the coastal. So basically, that is how the earthquake triggers a tsunami. The ocean waves are developed through the earthquake waves. The earthquake waves trigger ocean waves, and as a result, we have violent waves from the ocean, which will tend to swell out of the ocean and give negative implications on the areas close to the oceans. Discuss the importance of prediction and preparedness in reducing earthquake-related death. We are looking at the importance of predicting and being prepared. Right, for example, prediction, it helps to know when people may avoid vulnerable areas. If you predict, and we know that maybe next week there's going to be an earthquake, then it helps people to move away from areas which are at high risk. Areas which have got strong waves, we know that there's going to be distraction. They will move away. Then preparedness. We know that an earthquake is going to come. We must prepare for it. How is this? People will keep stocks of resources, e.g., food, water, medical. So if you are having preparedness, it means you have to keep yourself enough stock of food and water and also medications, such that in case the earthquake causes distractions and the homes are destroyed, you know that you have your food kept aside, you are going to sustain after the earthquake. You have your water storages, which are going to sustain you after the destruction, because we know well that if an earthquake is destructive, it is going to destroy the water supply system. So we need to store water ahead of the situation, so that when the earthquake is over, when it's erupted and it's over, we might have stocks to use after that, instead of us not being prepared and everything gets under destruction, and then we will not have anything after that. So that's the picture of what you must address for question 2.5.5. That brings us to the end of the geomorphology question number 2, and that marks the end of section A, which is our theory section. So what we need to do now is to transit into section B, which is our map work question. So we are moving on to question number 3. Right, our map question is based on Queenstown. There is map information provided. Right, we are going to answer the first part, which is a multiple choice part. Queenstown is located in the province of What you need to do here, if you are supposed to answer this question, you use your map information. It says Queenstown, named after Queen Victoria, is a town in the middle of the Eastern Cape province of South Africa. So automatically your answer, you find it in the map information, is in the Eastern Cape. Then the next question is saying the coordinates of spot height 1257 in block E2 is approximately. All right, you go to block E2, you find the spot height 1257. So we go to our map, we go to block 1257. I'll just highlight how best you can find the coordinates. Right, we want to look at block E2. Our block E is here, block E2 is this, and our spot height in question is this one here. So what do you need to do here is your spot height is there. What you need to do here with this particular question, you need, we'll try to enlarge to make it more visible for the sake of clarity. Right, there is our block with that spot height there. We need to find coordinates of that particular spot height. So what you do here is already you are provided with the degree value. Always remember when you are giving the coordinates, it's longitude, then latitude. Sorry, it's latitude slash longitude. You start with your latitude value and then you go to your longitude. You start with latitude values of coordinates, then you go to your longitude values. So what you need to do here is your map reference can give you the degree values of latitude and degree values of longitude without wasting your time. If you go here, 3126, this is our map reference. This 31, it represents 31 degrees to the south latitude. And this 26, it represents 26 degrees to the east longitude. Or you can go to the top left corner here. You see there is 31 degrees, which is representing these lines of latitude. And there's 26 also representing these lines of longitude. So on top of that, you need to figure out your values for the lines of latitude for minute value, because your degree values don't change for this whole map. They are basically 31 degrees latitude and 26 for this whole map. But what is only changing there is your minute values and then lastly your second values. This is 3145 degrees to the south. Automatically it means the next line of latitude is going to be plus 1 minute, which is 46 minutes. And as we go further down, for every line, it means it's going to increase by 1 minute. So it's 47 minutes. It's going to be 48 minutes to the south, and it's going to be 50 minutes, and it's going to be, it's 40, 45, 46, 45 minutes, 46, 47, going down like that. Then going to longitude, it's 45 for the first line. Then it means the next line of latitude, longitude to the east is going to be 46. It's going to be 47. It's going to be 48 minutes to the east, going like that until the end of the map. Right, so we want this block here. Our block in question is block E2. Right, we want this spot height. So we can safely pick our lines of degree value latitude and degree value longitude. That is obviously available for us now because we just had to trace those lines of latitude and longitude for minute value to find out how much is it from the line of latitude and the line of longitude. So basically you use that and you figure out it has 45 minutes to the south, it has 46 minutes, it has 47, it has 48, it has 49, sorry, I skipped the number here. It must have 49 after this. 48, 49 minutes to the south. Then it gets to 15 to the south is labeled already. So remember our coordinates in the southern hemisphere, we pick them from the northwest corner here. So in terms of lines of latitude, already we know that our degree value, we have the major line of latitude in degrees is equivalent to 30. Here is 31. It's 31 degrees. It's already provided for us. 31 degrees. And then what is the line of latitude for minute value here? Is 49. We are seeing that it's 49 minutes. Then we will estimate the second value. Then we go to longitude. Our longitude, we are told that is 26, and it's obvious it's not changing, 26 degrees. Then we also check here the value of this line. What is the value of this line of longitude? This is 45. It means we are progressing, going to the east. It gives us the next line as 46, or how we labeled it on top here, it's 46 minutes. So it means it's also giving us 46 minutes. Then what we need to do there is us to try to estimate the longitude and latitude positions. Right, we try to estimate by using the central position of our line of latitude here must come somewhere here. If you are to divide this block, which means if you are dividing this, there is 1 minute from this line to this line, meaning to say 1 minute is equal to 60 seconds. So for that matter, it means our 30 seconds, we estimate them here for latitude. Then if we go for longitude, we try again to subdivide our block into half. This will be our 30-minute line, 30-second line of longitude and our latitude. So slightly, if we are to add the 3/4 line, it will come somewhere here for latitude, which will give us 45 seconds. And also if we will add a quarter line here, it will slightly come somewhere there. So it means for longitude, our estimation is somewhere close to 15, and our estimation for line of latitude is somewhere in between 30 to 45. So by merely comparing our answers, we can try to check there, because already we have the correct response of 31.49 degrees and minutes, 26.46. So we can odd out any answer which does not have 31.49 for latitude and 26.46 for longitude. So using those values, we can figure out 31.49 is fine. Then we said 26 and 46 is also correct. This one also is fine. Fine. And also this 26.46 is correct. But this one automatically is out, because our degree values are even wrong and the minute values are wrong. This one also is out. Your degree values and minutes values are also wrong. So trying to estimate there, it's saying 50-50. But if you also check the sequence, here it's wrong, the direction. So the direction does not have to be east for the first coordinates, because it's latitude first, then longitude. So this one automatically is wrong. So automatically the answer that qualifies to be correct is that one. 49.50 for latitude and 46.20 for longitude. So 50 minutes for latitude and 20 minutes for longitude, which is equally justifiable. So basically that is how you estimate. And also you odd the you remove the odd response there. If you use your understanding of coordinates, sometimes you tend to find that the degree values are wrong, then you odd those answers out. The direction also might be wrong, you odd them out. Like here, we have ordered them out because of the wrong degree values, and also this one is wrong in terms of direction, and we only have one correct response there, which is A. Then convert the ratio scale of the orthophoto map to word scale. Word scale is a statement. Our ratio scale is 1 to 10,000. That must be obvious for every geographer to know the ratio scale of the orthophoto map. So we want to convert this to a statement. It means 1 centimeter on the map is equivalent to 50. Not 50, rather, I'm using the wrong scale on the orthophoto map. Is equal to 10. 1 centimeter on the map is equal to 10,000. Is 10,000 centimeters on the ground. So you must just have supposed to write it in words. 1 to 10,000, what does it mean? It means 1 centimeter on the map is equivalent to 10,000 centimeters on the actual ground. Calculate the difference in height between spot height between 0.6 and 7 on the orthophoto map. Difference in height, just you have to identify the 2 points and then subtract the smaller value from the bigger value. We are calculating the difference between 0.6 and 7 on the orthophoto map. We go to our map. This time we want to use the orthophoto map. Our orthophoto map is this side. We need to find 0.6 and 0.7. Right, 0.7 is here. Our height is 1,567. This is in meters. And this is 0.7. And then 0.6. 0.6 is an index contour line. How do we find out the height of that particular contour line? We are supposed to check it around and try to figure out what the height is. Right. Let's find out. This is 1,420, which is indicated on this measure, on this value here. And if we trace the same line, is the line on 6. So it means the value of 6 is 1,420, like that, meters. So between these two, we subtract the smaller from the bigger one. So we are saying our difference in height is 1,567 meters, subtract 1,420 meters. What do we get if we subtract those two? It gives us 147 meters. This is our difference in height. Then, moving on to the next question, it says, determine the true bearing of spot height 1313 in block D2 from spot height 1515 in block C1. Right, I'll just illustrate what you will do there for the sake of clarity of how you find your true bearing. Right, we are referring to, we'll see where the spot heights in block D2 and C1. Block D2 and C1, I'm going to reduce our map and look at block C2 and D1. Right, it says the difference in height, this bearing between spot height 1313 in block D2 is not referring to the orthophoto map. Let's go to our topographic map. Block D2, our spot height 1313 is here. And we also need to identify the other point, which is in block. We have true bearing from spot height 1313 and spot height in block C1. C1 here is 1430, 1515. This one here, not 1438. It's 1515 here. Those are our 2 points. So where from where we are having these 2 points? We want to determine the bearing. Calculate, determine the true bearing of spot height 1313, which means we want this one from this one. So what it means here, is, if you have identified your 2 points, can you please be specific on identification of the correct points of where you are supposed to measure your bearing from? If it's saying bearing of 1313 here from 1515, it's here, which means you draw your compass here. You draw a parallel line to your lines of longitude, which means you must draw a straight line using your ruler, and that must be parallel to your lines of longitude like that. I understand maybe it's straight, though I'm not using a ruler. I'm just trying to draw that. You draw a straight line through the dot of the spot height, and then you draw a line connecting the center of your focal point of your origin. You use your ruler to draw a straight line that joins the 2 points. You can continue the line because sometimes it will be too close and won't cross the edge of the protractor. You can continue it like that. As long as it's a straight line, which is straight from the origin through the point in question and wherever it goes there, it must be straight. Right. So with this being said and done, we now have to determine the angle that we want. This, for the sake of this being a parallel line to lines of longitude, this is your true north direction. So our true bearing, we always measure it in a clockwise direction from the true north direction. So it means we want this angle here. This is our angle in question, from true north to the line connecting the 2 points. So what you do now is you take your protractor, you place your protractor, the center of your protractor must come here. Again, at the middle point of your protractor, there is a center marking. You put your center marking just here and align your 0 to the top, the north direction, and your 180 on the protractor must be here. So your protractor is a semicircle like this, which means it must cover something like this. Your protractor, it must be like this. And your protractor's 0 marking must be there, 0 degrees. And obviously, your 90 degrees will come here. So you check the edge of your protractor and find the reading here. The reading on the edge of the protractor where your protractor crosses this line. And remember, use forward bearing. We are starting from 0. Use numbers that are increasing because on the protractor there are 2 sets of numbers. Others are increasing from this side, going backwards. Others increase from this side, going forward. Use forward bearing because we want to measure from the true north. So your 0 must be there, then check for continuous numbers until 90, then it passes 90. Your true bearing here, if you are accurate, if you are precise, make sure that also the line at the bottom of your protractor is along this line, the north-south line. It must not deviate from this line. It must perfectly be on top of this line. That is why your protractors are transparent, so that you can see what is at the bottom of your protractor. So if you are accurate enough, you will get this angle as 115 degrees, 115. Or if you can see my estimate here, 90 is just here, which means from 90, slightly 100 and 115. So that is basically how you get your true bearing. And remember to always put your units of measurement. Your bearing is always given in degrees. Right. Then let's go to the next question, number 3.1.6. It says, will the magnetic declination for 2024 on the map be greater than or less than 26 degrees 25 minutes west of true north? For 2024, when was this information of 26 degrees 25 minutes discovered? We look at the bottom of our map. It says mean magnetic declination is going to be 26.25 west of true north as of March 2017. Remember, for places in South Africa here, our mean magnetic declination is always to the west of true north, which means this angle will keep on increasing. So for 2024, it means it's going to be greater because it's increasing by 10 minutes every year. So from 2017 to 2024, they are increasing by 20 by 10 minutes for every year. So automatically that means it is going to be greater. It will be greater. And the reason I have given already, mean annual change is westwards. So it being westwards, so the change is added. I understand you know how you calculate your magnetic declination. If the change is an average to the west, it means the angle is increasing and we add. If the angle is the declination is to the east, it means the angle is declining and we adding. Like we are saying from the true north here, and there is an identified angle here. Maybe the angle is now is 26 degrees and 25 minutes west of true north. Our true north is there. If the mean magnetic declination is increasing, is going to the west, it means this angle is getting bigger as we go to the west. But if it's going to the east, it means we're going to subtract. So for South African places, the change is always to the west, which means this angle keeps on being greater and greater because every year we are adding. For that reason, the angle will increase with a change in time. Right, let's move on to the next question. Length from H in block B5. Let's look at length from H in block B5. Right, our block B5 is here. We have this length from here. What kind of a length form it is? You are seeing that there is a stream here and our contour lines are bending upwards like that. So what kind of a length form is that? Automatically, that means it's a low-lying area, which is a valley. That is a valley. The height of the dam J in block A3 is dash above sea level. The height of the dam J in block A3, let's just look at it. Block A3, the dam J, this one here. What is the height of this dam? It means we have to find clue on this contour line here. What is the value of this contour line which is passing by the dam wall? Right, if you trace that contour line, you trace it properly, you tend to find that it's written 1,400 here. This is an index contour line, it's a bold one. If you trace it, it's the same contour line coming all the way there, up to the dam, going that side, going that side, going like that. So the height you find it here is 1,400. You need to be very observant when dealing with the maps, especially identifying heights of unknown points. You need to look closely. It's 1,400 meters above sea level. What is the importance of the dam marked J? Obviously, the dam is used to store water, storage of water, and it can also for irrigation. If you check the area, it's got cultivated land. So it's storage of water for irrigation, or basically you can say for the cultivated land. That's the importance of that particular dam. Provide two map evidence to provide that town of Queenstown receives seasonal rainfall. Right, we are saying this place is receiving seasonal rainfall and not rainfall throughout the year. We need substantial evidence from the map to support the idea that this place that we have, it receives seasonal rainfall. Right, the clues that you use here to say a place receives seasonal rainfall, check for the type of rivers and the type of water storage facilities. Right, if you see a place with a number of non-perennial rivers, it shows that the area receives seasonal rainfall. Like for example, this river here that you see is shown by a broken line, this river here. And also if you check here, these rivers, they are shown by broken lines. And also if you check further to the north, all these rivers, they are shown by broken lines. So it's one evidence that we have non-perennial rivers. They give us evidence of seasonal rainfall. Those non-perennial rivers, we are saying they are rivers that do not run throughout the year. They don't flow throughout the year. They only flow during the rain season and they dry up during the dry season. So if the area is receiving continuous rainfall throughout the year, it means that we will all be having perennial rivers. And then we can also look at the clue that you can also check if an area has got many dams. Like here, there's a dam, there's a dam there, there's a dam there, there's another dam here, there's another dam there, another one is here, another one is there. We cannot finish them. So the area has got many dams. It shows that water is scarce because dams are there to store water and use it during the time of uh, need. Many dams in the area is also another piece of evidence. And also if you check, this is a wind pump. This is a wind pump. This is again a wind pump. Another one here. There is another one here. Another one is there. All those wind pumps. There are also many wind pumps in the area. What is the purpose of wind pumps? Is to extract groundwater. If water is readily available, it means we have surface water supply. Then there's no need for us to drill water from underground. The fact that we extract water from underground is evidence that there is limited water supply. We only resort to groundwater storage because there are ground surface water facilities, they will be dry. So the wind pumps, they give evidence. The dams, they give evidence. The non-perennial rivers, they also give us evidence. Right. The gradient A1 and 2 northwest of the orthophoto map is more steep or gradient or general. Right, we just look that for that by the mere spacing of the contour lines. We need to look at block A1 and block A2 and see how the contour lines are spaced. So we're going to the orthophoto map. We look at A1 and A2, right? A1 and A2 here. What would we say? These contour lines, A1 to A2, this part. The contour lines are close to each other. They are very close to each other in this block. This is a steep landscape. So basically, because of the spacing of the contour lines, we can say that one is a steep. Provide evidence from the orthophoto to support. We have already given the evidence. Contour lines are close together. So the reason is that the contour lines are closely spaced. They are close to each other. That means that is a steep sloping area. Based on the background information and the area of Queenstown, is often affected by natural disasters. State 2 natural disasters that affect this area. That is basically background information. You refer here to the background information and you find out the nature of the natural disasters that we find. In 2002, there was heavy snowfall that caused a severe disaster. Affected also by strong winds that also caused damage. And also, you look out for other map information. There's also risk of flooding. So, wind damage, flooding, heavy snowfall. And also, if you check, it talks also about droughts. So, you just use the map information and figure out the natural disasters. So, basically, you figure it out from the map information. There's no need to worry there. Explain the impact of the topography of an area on the infrastructure development. Right. How does topography affect the infrastructure? Explain the impact of the topography of an area on the infrastructure development. Right, we can relate to the map, but I will give you the general understanding of the area. Right, if the topography of the area, we have steep slopes. If an area is steeply sloping, What is the implication on infrastructure development? There will be less roads or railway lines. Why? Because it's difficult to construct in those areas. Talk of buildings. If the area is steep sloping, they will be limited. Why? Because it's expensive to construct in steep sloping areas. So you look at the different forms of infrastructure, like communication infrastructure, power supply. It will be difficult for those areas to have such infrastructure because it is very difficult to access those areas. Like railway lines, they need flat areas. Then the opposite is true. If it's gently sloping, this is where you find a variety of infrastructure. You can find golf courses being developed because the area is flat. Some recreational grounds will be there because the area is flat. We have good roads and national roads in those areas, and also railway lines. We have good buildings, plenty of them in that particular area. Mainly the built up areas will be in flat areas. So you just have to compare how a gently sloping area or a flat area influences infrastructure development against steep sloping areas. Right, we move on to question 3.3, which is our question on GIS. Right, it says identify the following. We are looking at block A1 on the topographic map. We want to identify one, a point feature, a line feature, and a polygon feature. Right, we go to block A1 on our topographic map and try to figure out those factors. Right, our topographic map is this side. Block A1, let me clear the block and let us see clearly. There is our block A1. I'll try to enlarge it for the sake of clarity so that we can see. Right, there is our block of interest. We are worried about this block here, A1. Right, in that block, we want a point feature. This is a point feature, a spot height. And if you also look closely, you can see that there's a wind pump. It's also a point feature. This wind pump is also a point feature. And also, if we look closely, there's a reservoir here, and a reservoir there, and a reservoir there. All those are point features. So we are saying point features identified here. We have found one, a spot height. We've also found a wind pump. And also, we have also found a spot height, a wind pump, and also a reservoir. Those are the 3 point features. Then we also want to find a line feature. Right, what are our line features then? If we look closely, we have this is a hiking trail. It's a line feature. And these lines here, what are they? These cannot be power lines. They are farm boundaries. It's another line. And also, if you check, there is a river here. It's also another line feature. Is there another line feature then? We can also see this is a road. It's another line feature in the block. Do we still have any other? I think those are the line features that we have. So we can safely say for line features, we have treks, we have hiking trails. Hiking trails in the area. And also we have seen a river, a number of rivers there. We've also seen that there's a road. And also we've seen that there are some farm boundaries. Right, those are the line features. Then the polygon or the area feature. We are looking at a feature which is covering an area. Right, if you check here closely, we want to identify line features, aerial features. If you see this one, it's an area because it's covering the 3 dimensions. It has an area that is covered. This is an area feature. And also if you check around here, there's cultivation taking place. This cultivated area is also an area feature around here. So if you check there, and also this area here is area, the eroded area. This one is also a polygon feature here. These ones, the eroded areas, they are also polygon. So if you check on those ones, our polygon features, they are basically this here and this cultivated area and this dam here. Those are our polygon, our major polygon features. Remember, when I'm referring to polygon features, we are saying they cover an area. So a dam is one example. And also if you look, we also check on erosion and sand, and also you look at cultivated area. The cultivation is also an area feature. Right, that is with the point and the line with the area features. So what you need to identify there is just to be able to figure out. All right, moving on to the next question, that is an illustration. Define the process represented by the fig 3.3.2. Right, the process which is being shown here is actually seeing, we're actually seeing that there is some form of collection of information from the Earth's surface here, but the collection is done from space there. So if you are defining the process, we are saying what is happening there is the collection of data about Earth. Is collecting data about the Earth from space using satellite imagery system. Or we can say collection of information without contact with the actual space. So we are seeing that there is some form of collection of information, but there is a gap between the Earth's surface and the tool collecting the information. That is what you call remote sensing. Name any tool that can be used for the process. What can we use to do remote sensing? We can use cameras. For example, using the drone system, the camera can focus from above and be able to gather data about the Earth's surface without being in contact with it. Then also we can use satellites. The satellite images, they give us the images of the Earth from space. Then the last question, it says, explain the role of people in GIS. The personnel. The people are the users. Of the GIS information data there. Or we can say the people also, they are operators. They are also operators of GIS. They are the ones who operate the system. They gather the information, they feed it into the computer system. And then when they want to use it, they become users on the other end. So, and also we have designers of the systems that we use that would design software. Those are specialists who operate the system of GIS. So basically that's the picture of the role of people in GIS. Right, with that being said and done, I can say we have come to the end of this discussion. This brings us to the end of our section B with 30 marks and the grand total of the wallpaper being 150 marks. So I can safely say we have done justice to this particular setup of a paper, and I think this is going to assist you in preparing for your June examinations. So thank you for watching until we meet again in other discussions to follow your host in geography.
Welcome to Thundereduc, an online learning platform powered by professional, highly skilled and qualified educators.
We deliver structured CAPS online lessons for high school subjects, including mathematics, physical sciences, life sciences, geography, business studies, history, accounting, English, Afrikaans, and others.
For the intermediate and senior phases, we offer expert teaching in natural sciences, mathematics, social sciences, English, and EMS, designed to build strong academic foundations.
Access the distinction material books by clicking join button on our YouTube channel or download Thundereduc app on Google Play Store for all our study material and past exam papers.
Thundereduc offers extra classes for rewrites, old curriculum, and other students from grade 4 to grade 12 through online and physical classes.
Subscribe to our YouTube channel, Thundereduc, for reliable curriculum-focused learning and stay updated with the latest educational content.
Please like, share, and turn on notifications so you never miss a lesson.
Visit us at www.thundereduc.com
Or call 0786 636 613 or 084 833 1738 for more details.
Thundereduc, we focus on quality.